The sort of theme in our lab is using pluripotent stem cells for cardiac repair. So human embryonic stem cells and iPS cells is what we've studied the most. We focused mostly on the use of those cells for repairing myocardial infarcts or hearts after a heart attack, but with a particular kind of emphasis on electrical issues related to that, because as you know, the heart isn't just a mechanical organ, it's also an electrical organ, and seeing how cell transplantation affects the rhythm disturbances in the heart. We've also done research to see if we can make pacemaker cells from stem cells to try and replace electronic pacemakers. Sort of the unifying themes, I guess, of the lab are stem cell therapy with sort of an electrical bent. I guess I'm the kind of person that likes instant gratification, and heart muscle cells do something that you can see in the dish. It makes them fun to work with. So hepatocytes and renal cells are doing important things, but you don't find out what they're doing for days later when you run a gel. A heart muscle cell is doing something you can see firing in the dish and contracting. I guess that's always made it fun to work with. And even to this day, I mean, we can make these stem cells into heart muscle cells that are spontaneously contracting, and sometimes you can see the tissue beating in the dish. And I've been doing that for a long time now, and I still don't get tired of seeing it. So I know that's kind of a funny reason to have gotten in the area, but I think that kind of visceral reaction, at least early on, drove me. So. Yeah, there's been a few. I mean, the two that immediately run to mind. I mean, there was my PhD mentor, Peter Becker at Emory. You know, was a role model in many ways, and somebody to look up to. And then more recently, I came out to Seattle in 1999 for doing a postdoctoral fellowship and also for residency training in pathology. And my mentor for both those was a guy named Chuck Murray that was, you know, sort of one of the early folks in cell therapy for the heart, and very much a role model as well. So, and both those folks were, you know, very gracious with their time and advice, and there's been countless other people that I've interacted with as well. Yeah, I'm really flattered by the honor in the first place, and then when I look at the other speakers that are also being honored, I mean, it's a pretty august company, so I really do appreciate it. I guess I've never considered myself the type that looks for honors or likes to blow their own horn, so I guess I appreciate the visibility and the award. You know, I hope it can bring some visibility not just to myself, but the people in the lab that, you know, quote unquote, do the real work. As well, and as you probably know, it's a tough funding environment, and so this kind of endorsement, I guess, also helps with that as well. I mean, I've always been sort of a translationally minded person, and so I guess I would consider it a failure if ultimately we can't make a therapy out of something that we're doing directly or something that you can learn from the research. So I hope that that's where I can make a difference. I deal with both sides of the equation as a researcher that studies heart research, and then somebody that's also a physician that's dealing with people that you know, have heart disease, and so I'd like to see something useful come out of it. In terms of society, you know, there's some really exciting things going on in cardiovascular gene and cell therapy, and so, you know, going forward, I can help with that in the society, and, you know, get other people visibility. You know, I'd be really pleased to help with that as well. The obvious thing is the national meeting. I mean, that's the thing that you know, in all these societies you look forward to going to every year as a trainee, and, you know, starts off as a reward when you're a graduate student, and then later on becomes something that's important for, you know, learning scientifically what your colleagues are doing, networking, that kind of thing. So that's the most important thing. I said I felt a little bad about having to truncate this meeting because of the pictures duel I lost here recently, but I always learn good things. So that's the most, you know, valuable thing, I think, with the society. And the other thing is, I mean, there's maybe half dozen journals that I keep bookmarked on my computer. Maybe, you know, it gets fewer and fewer over time as things become more electronic, and there's robots that will give you the links. But molecular therapy has always been one. I think I've kept that on since I was a grad student. I guess first would be patient. I think things, the good science takes time, and I'm always having to remind that to the grad students in my own lab that, you know, if we knew every day the experiments that were going to work and we just could show up on those days and do an experiment, you know, it probably would take 10% of the effort that it does. The other thing, and maybe I have a little bit of a conflict of interest, because the particular cell types we've been interested in are kind of earlier in the developmental pipeline. But I guess I've experienced people saying, you know, this won't work. This strategy doesn't have an obvious route to the clinic. And I think if you said that about some of the things that are now in the clinic, you would have been proven wrong, right? And so, you know, that's one of the refreshing things about this society. You know, I think cell and gene therapy, or you know, particularly gene therapy, are now becoming reality when there were a lot of naysayers. And so I think, you know, sometimes you have to be a little bit of an iconoclast to succeed in this field.